Hello, Steve Ansell here. Been working on a project this morning, just something I've thrown together because I was a bit bored. Little device here which an LED takes usually 3 volts to light up. This thing here, I've actually just quite literally got this thing running on that one battery. Now in reality, if you used to connect that battery directly to that LED, it wouldn't light up. What this thing does, it's a blocking oscillator. It's like a bit like an inverter. Very low component count. Unlike the one I've done recently, the one which I had 8 LEDs running on, which could actually run on a higher voltage, because I've used thicker wire on this toroid transformer that I've wound this morning. Took me absolutely flipping ages to wind that as well. It won't actually run the LED. What it does, it oversaturates with the magnetic field, and it just don't light up. So this one is only capable of taking an input power of just one battery, but you can use any 1.5 volt battery. It don't even have to be fully charged. Usually if you're using a 1.5 volt battery, you usually throw them away after you get down to a voltage of roughly about, I don't know, I suppose about 1.1 volts, something like that. That's when you usually any device would actually class that as being dead. This battery here is, if I put this in my blood pressure monitor, it'll actually show up as a dead battery and the device will fail. But this one, I'm going to just put this here. That's pretty, I'd say pretty bulby bright at the moment. I mean, if I look at that directly with my eyeballs, it's quite sort of hard to look at. It basically gives you a proper blotch in your eyeball. But all this thing runs on, it's just a piece of Strip board that I just cut off of one of my big pieces. It's got a 1 kilo ohm resistor running from one side of the toroid to the base of this transistor. The transistor's just basic 2N3415. You could use a 2N2222 if you wanted to. It will do the same thing. Any sort of general purpose transistor will work. The LEDs is one of them high brightness, higher current type. Think they take about they draw about 50 milliamp. This thing will actually run. If I was to leave this on now, it'll probably run probably for the rest of the day, probably through to the next day, maybe through to the next night. I mean, on my last muck around project, which I built on this variable prototyping board, I mean breadboard, whatever you want to call it, I was running 8 LEDs with one battery, and I run that for like, I think it was about 13 hours, something like that, before it went completely flat. So I couldn't actually tell you offhand how long this would last on one just one LED. But yeah, it's what this circuit's actually called. Like I mean, they've got a few different names. I mean, it's proper names. It's basically it's called a blocking oscillator. What you do, you wind. This one's got 8 turns of each colour on it. Like so, what you do, you put the 2 wires together, you wind them round, so you've got 2 what's called a bifilar winding. And then what you do, once you've wound them, you take like one colour from one end and the other colour from the other end. You connect them 2 together, they become a centre tap kind of thing. So like on the board, I mean, you wouldn't be able to see it because it's so compact now, but on the actual back of that board, where that orange wire is in the middle, like on the front, there's actually a white wire which you can't actually see properly, just the belt. If I look right down in there, you'll just about see a white wire going under. Those two are connected together on the board, and then on one side you've got an orange wire in the board, and on the other side you've got a white wire in the board. Actually, I've got that the wrong way around. This side's actually the orange wire, this one's the white wire. And what it does, you put a positive to these two twisted together or connected together, and what it does, it starts charging up the coil down the secondary side, which runs to the collector of the transistor into the LED. And what happens when the magnetic fluxes come to saturation, where it's no longer changing, like when it becomes stabilized, it then causes the magnetic field to collapse because the transistor shuts down. And then what it does, because the transistor shuts down, it then causes the other coil to charge as well, which then causes a changing current, which causes a build up of a magnetic flux, which at the same time, it's when it gets to saturation again, it fires the base of the transistor. What it does it over and over and over again. It causes an oscillation, which then makes that transformer. I mean, on this one you wouldn't be able to hear it, but if you make these like a bigger type one, they actually make a ringing sound. So sometimes they're called a ringer circuit. This one's obviously so small you wouldn't hear it do that. But like I said, the correct name's a blocking oscillator, but they're more commonly known as a vampire torch circuit, or sometimes a Joule thief. Joule as in the unit of energy joule, not as in the diamond. Joule, in other words. And thief, the reason they call it a Joule thief is because what it does, it robs the battery right down to 0.4 volt or somewhere thereabouts, or 0.3 sometimes to go down to. Depends how well you design this circuit. I mean, this one is a very crude one, and I thought I'd use thicker wire to see what happens. If I was to wind it with thinner wire, like my other one that I'd done here like about a week and a half ago, this one will actually run on 3 volt or more without oversaturating itself, without like getting, so the magnetic flux can collapse quicker to keep this thing going. Because this is stronger wire, it actually overcurrents itself, because the LED is not actually capable of drawing that amount when it's being dumped that quick. Not only that, it's not a lot of turns. There's only 8 turns on this, as I said. But what these can come in handy for, if you're in an area where you have a lot of blackouts, you could either build this one or build the other one with the other coil I've just shown you, and you could have this as emergency lighting. And in theory, you could, like where they do these experiments where they stick a couple of electrodes in a spud or a piece of fruit, you could run this off of that, I reckon. I mean, I haven't tried it yet, but I will do at some point, because I'm going to build a few of these, but I'm going to wait until I've got myself a decent one built. I mean, this one's basically a mistake. I'm just going to keep it built like that, just as a showpiece. But I mean, it could come in handy for something. But what it is, you could technically make yourself a smaller board, make yourself like a 1.5 volt source. It's pretty bright. But there's also another experiment some people do on YouTube, where they stick electrodes into the ground, into the mud, and I've always thought to myself, right, you put it in the mud, like, and you try and draw more than, say, half a volt, or sometimes a volt, depending on how good your electrodes are, you're not going to get much more out of it, because you're stuck. If you used to stick loads of plates like you would a battery like instead of just one cell like you've got here. I mean, if you used to actually make yourself a box, put some copper and zinc plates in there to make like effectively a battery, and you used to actually dig mud out the ground, shove it in there, keep it moist, put like cling film over the top, like you do with them window boxes, like where you put your plants in to keep them like humidified, if you know what I mean, keep them humid. You could technically do that and probably run this off of that kind of thing, but I'll keep that as an experiment for later on. Like, I'll keep you posted on this, and like I'd actually try trial different methods, like see what I can run these things on. But I mean, what I'm going to do, I'm going to put a link on the video when I upload this to the, because there's no point in me actually drawing my own circuit, because I've copied this circuit off the internet. So what I'm going to do, I'm going to put a link to the circuit that I actually based this on, and you'll just see how simple this thing is. I mean, even if you're not into electronics, you could still sit here and build this thing, and it'd probably work. But obviously you need to be into electronics to actually understand what makes it tick. I mean, I've been dabbling with electronics for donkey's years, and I'm not very good at explaining stuff. I mean, obviously, because I've got a communication problem anyway. I've got Asperger's, but I'm better at doing things rather than explaining it. So that's why I sound like I'm rambling on a bit. I'm not exactly the neatest of workers either. My desk is absolutely flipping scattered with stuff. Well, I've even got the Dremel sitting up on top of the PC. But anyway, that's my. I'm going to stop rambling on about this. I think I've explained enough. But let me know in the comments. Like, I mean, if you think I'm a complete and utter scatterbrain and I'm as mad as whatever can be, like, feel free to say that. If you like the circuit, put a thumbs up. Subscribe if you want. Don't make no odds to me because I don't monetize my videos anyway. But I mean, I've got other videos on there where I've mucked around with Arduino and all that kind of stuff. But yeah, I'm going to leave it at that. Right. I hope this was interesting to you, and keep an eye out for my next video. Like, my next videos, I should say, because I'm going to be working on a lot of things. Alright, this is Steve. This is me signing out. See you later.